How's it going, everyone? Welcome. Elier Gonzalez here. So let's take a look at the React hook, part of the course taught by Josh Kamua. Kameu, a software engineer that previously worked at Khan Academy and then at Gatsby. So now in 2020, he created now this particular course to kind of map and create this story of how do we get here with React. And this is to me one of the things that capture my mind, that seduce me, and I will argue that it will do the same for you. So pretty much if you had grandparents or somebody all in your community that you actually now pay attention to what he say, uh, so most of the time that's what we did when we are young. So we look now at the eyes and the lips of the narrator, all right, in this case, or grandfather or grandparents or somebody of authority or in our community, right? Because the way how express things and how it makes sense, this is a common pattern that I have seen that to me has worked out. And the reason why I'm actually taking notes out of this course so I can understand how do I get here, and especially when some other clients out there say, hey, I do need you to build this particular interface, I know what I have to do and what is the end goal of this, what am I getting paid for, right? Which is important as a front-end developer, right? Front-end and UI designers, so that kind of stuff. So because as a front-end engineer, you or full stack engineer, you're gonna be paid is for how well you can now connect these two pieces, the front end and the back end, developing his user interface, as well as maintaining the server and do some data treatments here. So that's the role of the full stack engineer, which is at the end of the day something that you're gonna do. And if you want to build some specific products for X, Y, and Z reason, this is the basics. You need to know is the front end, HTML, CSS, and JavaScript. And right now using is React, right? The convenient way of using perhaps React, right? And maybe going using now next frameworks, okay. And also is that how now the communication happen between one computer and another computer systems over the cable, especially using HTTPS, and how the communications is, so how that happens through the OSS or the open system interconnection, is that how you make sure that two different computer architectures, no matter the hardware they use or the OS, I don't care, as long as both of them implement this open standard, the open standard of interconnection. Now, this architecture, these computer systems, in our case, the client and the server, now they can communicate, right? And it is made of 7 stage. So from the application, which is now going to transform that into data ready to be transmitted, and on the season, on the presentation, is going to prepare that data according to what needs to be sent over. And also this is when the encryption happens, that you have now the presentation layer. I mean, is first the application. I do think this is quite relevant to recap here. In fact, I do have that, the OC model. Let me put it here. I know, I just want to make a quick recap of that. The OC model here, all right, which is, let me see if exactly as it is, right? So it's on the application. In fact, um, di- di- di, uh, yeah, this was the fundamental of this Sir Chris Greer. Uh,
Welcome to this session.
that I find out that very 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 interesting and compelling. Again, again, um, the idea of this that was 7 years ago. Holy moly! I'm not sure if he's keep going this or he's posting this kind of content here. Oh, it is. All right. AWS went down. It was DNS. Find any package fast. Can AI analyze PCAPs? The results surprise me. Oh, that's another thing. Get Wireshark certificate. Wireshark just got a certification. Oh my god. Anyway, um, the intro to Stratoshark. That's quite also interesting. Don't push sensitive data to AI. Sanitize your PCAPs. Uh, Again, that's a couple interesting video where he mentioned, right? So, but in any case, in any case, um, analysis, shoot, and cybersecurity. So, the point of this
Welcome to this
is just to recap about this specific section. I didn't mention that. Yeah, the OC model. That when you explore the OC model from Cloudflare, right? So Cloudflare, all right. So he overview quickly of what this thing is doing. So now things started to make a lot of sense. Uh, the open system interconnection, right? So, oh my God, sorry, is this right? So you have now the application layer, which is the data that is gonna be ready to be sent over the cable, all right, in a human readable way. This is when this data can be accessed through the network interface and network services. And now on the presentation layer is going to be prepared everything that it needs in a format. And this is when data encryptions happens. And then on the season layer is when it's going to decide which port it needs to open up. All right, maintain connections, import and seasons. And then you say, okay, where am I going to send this? Am I going to use TCP or am I going to use UDP? Am I going to now need to connect to do I need as a computer to wait for somebody else to reply or just only send data and I don't care who is listening on the other side of the cable, right? And then you have the network layer, which is what is the physical path that this piece of information we need to look at that, right? And that is going to routers, switches, and other devices that are onto the destination. And then the data link layer, which is defining as the format of how now is the communication between end to end between the closest devices uh, before reaching to the uh, destination happens, right? And here, when you see things like, hey, how this communication, the data link layer, will be done, and then, and last but not least, once the systems, all right, once the system know what is the human readable data that is going to be sent and prepare that data in a format that is suitable to be transmitted over uh, it, yeah, it is ensure that the data is in a usable format, and this is when encryption data happens, right? So then I know what I'm going to send, but I need to know where I'm going to send that. This is when the connections and the season are established and maintained, right? So then you need to say, hey, what will be the transport how am I gonna send this data? Do I need to wait for somebody else on the other side to wait for that using TCP, or I'm just going with UDP, which is I don't care who is on the other side, and just continue to send data, right? uh, and whether transport layer you choose, you need to then identify what is the physical path that this data it will go over, right? So switches and routers until it reach to the destination, and then how the communication uh, needs to be done between devices, right? The closest devices, right? So, for example, if you have a computer directly with the Wi-Fi, and then the Wi-Fi with the other intermediary between that, which is usually is a server or the DNS, right? And so on and so forth. And then on the physical layer, it's like, okay, now I have all of this data and all of these informations that I know where I'm going to send physically, and I'm going to transform that into a raw binary data, right? So this is crucial to understand because this is what happens when you now send data from the clients to the backend, all right? And on the backend, which is another computer, right, it's gonna decode that data. So from layer 1 up to 7, now you already have that data in a human readable way, all right? And then you can do some stuff that you need to, right? And then on the backend, whatever backend you use, whether it's Node or Python, Ruby, PHP, yada yada yada. So this computer is dedicated to actually is handle, in our case, incoming web requests, right? Or serve as a web server. This is the content that I want to transmit over. This computer can be. This is one of the things that I really love about the AWS, where now the side is what is this server? What is the main common use case for this service, right? General computer, general purpose, okay, or do you want a a mm, a a computational something that actually I take note yesterday here. So a compute optimized instance, or in our case, is compute optimized um, uh, server. So for anything related to gaming server, or when you need a high performance web server, or any data analysis or machine learning processing or media encoding, right? Batch processing workload. So these kind of computers are quite different to these web servers. Uh, and the other kind of computer is like, hey, I do need to have this server is memory optimized. So for example, a wants to is now solve is or I want to serve content as fast as possible. So I do have a cache here, right? Uh, for distributed web cache, distributed web scale cache store, or in-memory database optimized for business intelligence, and application performance and real-time processing of big unstructured data, right? So anything that it needs to have when you need memory, or a computer more with memory than processing power. So this is memory optimized, and the other is a storage optimized. So hey, now in this case, I do need this to hold some huge collections of data, right? For example, OLAP or OLTP, right? Which is online transactions processing. This is useful for running data on a time base or an X amount of time, all right? And then somehow now dump into your storage, your hard drive or SSD, right? So you want to keep you want to have a backup data there. Or for example, working with relational or NoSQL database. Again, you want to now store all of this record here, or catch for in-memory database. Okay, or use that server as a data warehouse, right? So data warehousing application and distribute file systems. So this I mentioned this because all of this is part of the role of building user interfaces, right? And again, back to where we are, which is now here on this particular example and exercise. So this is the idea of why I actually is describing all of these things that I have learned and take note out of this as a story, because it makes a lot of sense, and this is what the mind is captured. So the TLDR of today's video is that I'm going to now explore about this React hook, these additional tools that we have in our toolbox, and explain why do we have that. Because since the way how write user interface in React is by defining its functions that allows to describe is the template, HTML template, as a GSX, right, as a markdown language, where at the end of the day, anytime that you define is a markup is transformed into JavaScript code, which is just a function call to React, create elements, right? And when that is called, it's going to generate now the UI at that specific moment. Okay, so this UI thing that when you want to provide now common things like rendering collections of elements, conditionally rendering elements, or apply now styles to this, you can do that using now JavaScript instead of creating your own templated language, right? So things like Blade, or in the case of Shopify, using is Liquid, right? I mean, you have now a specific templated language to help you cover these common use cases. So here we don't need to have it. We just only use JavaScript, which is one of the things that I love about React in this case, right? It makes quite convenient to go with. So when it comes to now adding interactivity to these components, all right, and that is by detecting user inputs, and that I would like to make a quick segue here to say, hey, the DOM event, uh, not from the standard, which is the living, but I would like to see that from a JavaScript info. All right. Yeah, there is a specific website there. Um, Holy moly, for real? I do think it's this. There you got it. Introduction to events. And the document, right? Walking down the document. So again, I'm just describing here is this, where it is, browser specific inspect, browser environment inspect, okay. It is on the document introduction to events. I think it's this one. No, it's not. UI events. No, this is part of the UI event form, documents, and resource loading. Miscellaneous documents. That's interesting. Mm, I do think it's this one. Okay, so why is this important here? Because here is describing uh, now how uh, these different inputs will go to, or inputs or tags provide some events based on that specific element, right? So this is just to show is a high level overview that comes from the living standard of the DOM, right? That's what they call here, you know. It comes from the living standard here, the DOM living standard. You can take a look at that. So I won't dive too much into this. But the here is that in order to capture now the events on from the DOM, right? So traditionally we did this is by, or and I mean traditionally is without React, is by just is attaching a callback to an event listener, or just calling that function in that event on the HTML tag. But because React is handling that for us, we need to pass is a or a function reference to that. So it's React that is going to call that function for us. And when somebody is calling your functions, so now you are in the realm of a framework. This is part of Martin Fowler, a software engineer that has worked in at a software engineer that has that's currently working at ThoughtWork, which is a multinational IT company based on Chicago that have a technology radar. When inside of there, it define is what are the things that are relevant for the software in terms of platforms, language and tools, so techniques, and the other that I don't remember right now. Let me check that. Exactly, tools and language, uh, tools and language, platforms, techniques, and frameworks, language and frameworks, right? Uh, so here describe that. Okay, and I mentioned just this because React is now calling our function for ourselves, which is now, this is the distinction of what a library and a framework is. And this distinction is important because when you now want to do some specific things in React, which is also how you can do that in JavaScript, right? So, for example, things like how do I remember some piece of information here in JavaScript, plain JavaScript. That's what we have now, closures. But how do I now is then cover some, for example, other use cases, right? So, for example, how do I guarantee that anytime that I'm so anytime that I call a function, I only call that once, right? Without having to run that function or execute that code over and over and over and over. And only do that is when I need it. So for example, this is now memorization techniques. So I'm just mentioning is these two particularly real use cases in our applications that now in the case of React is leveraging JavaScript, and for remembering piece of information it provides now an state, right? The use state hook. So here's when you can now see that common syntax. I'm not gonna dive deep too much into that, but what I do want to dive deep or describe is that any time that you want to now update that state via an event handlers is going to now pass through something called as the React core loop, right? Where it's going to now detect which depend of the scenario. If your application is on the first load, your application is going to now um, of a or React component is going to be now append all of these elements, right, into the DOM, right? This is on the initial render, and then when an event happens, so this is when React detect which components trigger that. Now render that, aka call the functions, and if that function contains more React elements, you're gonna continue to call that until there is no more elements to be called. AKA generating is a new snapshot, a new state of the UI, and then it's going to compare those via the diffing algorithm on the commit phase and apply only the necessary DOM updates to the uh, DOM. And then the final step, this is not part of the React, this is what the browser does. When it detects some DOM change, it will now paint that specific UI element, right? So this is the core loop in how you can also now, in when you are now scheduling this kind of event handlers or passing these functions reference, you can now is, well, update multiple state at once. So batch state updates, and that makes a lot of sense what the French toad means to me right now. And all of this async or all of these state updates are async, aka it happens in the next render. So why this is useful for understand all of this is that when you're trying to now recreate is not only lists of elements but also forms, and to provide now data binding to this via forms, well, a lot of the time it is important for us to understand how all of these different inputs behave without React, and then, and by inputs I mean is the text, the content area, the radio and check boxes, as well as the select, all right, text content area. And because now each one of them has a very specific way to detect that event or to bind that event, React say no, let's go into for type, uh, for input types, all of them except for radio buttons and checkboxes, and select. Uh, I'm going to define is this user interface, which is, hey, bind the value here, and this is on change how you're going to provide the function, the handler here, the function call. And then the specific use cases for working with checkboxes and radio buttons, as well as with select. All right. And then also using is now range to do so, but you get the idea of that specific pattern here. And then how you can now is working with complex data by storing is now object inside of that. And why do you need to always create is a new state out of that? How you can dynamically generate is identifiers using crypto to get random ID, or math random, usually crypto get random UUID, because with this you can now is tell React that this is a unique element, so it can now keep track of behind the scenes. So and then when it comes to write your applications, right, because all of this was just to describe user interface, but as you started to combine all of these user interface into pages and then into web applications, right, sometimes you need to depend on the use case to store data at a particular level, a component level, whether if you do that by state or lifting the state up, or by using now libraries for managing the state like Redux. Okay, so most of the time this application fall into three tiers, right? You have the landing page, the yeah, you have the landing page, the which requires minimal state. You don't need to have a global state for that. Or you have heavy client applications like gaming or some heavy interactivity app where you do indeed require is Redux, all right. Or then you have now server side applications, back office, SaaS, and that thing that the like. So this is useful, all right. This distinction of what are the three type of product that we can build here, because that's part of the understanding this, all right. And which is the and how these computer systems communicate, because with server-side applications, back office, SaaS, you there are a couple problems here. First, you want to get the right data at the right time using GraphQL, usually, or Apollo, or some particular tool that allow you to get that data. Uh, you want to now revalidate stale data. Now, after you do that, and this revalidation is using a particular technique, but you need to revalidate that data. You also need to catch that response, so you don't to avoid hammering the API, and then you also uh, needs to find ways to determine when this request will be resolved, right? Which is to avoid any race conditions. And the other issue is, yeah. Let me. I actually write it down here. And this is, and I'm going to hit the brake here because this is the problems. This is the real problems here. This is the real problems here. Mm-hmm. This is the real problems here. Mm-mm-mm. Where in the French though is this? Okay. That's good. I didn't put it. Yeah, I didn't put it. That's not good. That's definitely not good. Um, but yeah, it's state management tool is here. Uh, exactly. So relevant here and my own bias here. So this is the application type that I mentioned, right? Whether it's a landing page where there is not much state to have, or heavy client applications, or mostly server state. But for the server state, right? When you need to, as I mentioned, fetching the right data at the right time, you also need to make sure that the data doesn't grow stale by revalidating in a specific situations. Also, somehow catch that response to avoid hammering the API, and you want to predict how the response or how the request will be resolved. All right. This is for optimistic UIs. Interesting. Okay. Okay, optimistic UIs that you want to know or you want to predict how network requests will be resolved for optimistic UI updates, right? So for example, if user hover on that particular component, you already now fetching that data before it's clicking on that, right? And the other is pagination, right? So you want some slice of data and letting the user pull new data as needed. But all of these 5 problems here, right? Where there are specific tools that address most of this. So for example, you have now Apollo with GraphQL or React Query, as well as SWR which is the stale while revalidate, right? Um, which is just a using it is from Vercel, right? No matter which you gonna go, right? Regardless you wanna which you wanna go, right? Uh, this specific libraries actually solve these network related issues, whereas now Redux is not uh, is not suitable for this. However, Redux have this thing called RTK, which now is include this um, set of problems, they're network related problems, and they provide some tools to do so. So, yeah, that's actually something that I discuss here. But I do think that this is part of the problem that as we go deeper into React, from just building user interface to now building is landing pages or client side application, heavy client side applications, or now with a back office or SaaS application where the state live on the server, it is all about. But before going into that, right, we look at another toolbox in or another tooling or toolbox, because we have only components, and component has been used to not only define its user interface but also is things that are not relevant to the UI. So for example, like piece of information you want to share across your applications. So for example, some transitions or some routing or some states that you are fetching and then share that across different components. So React say no. Let's go into now is use hooks to actually first solve common problems in React applications. So for example is, hey, how can I have these unique identifiers in my React application using the use ID? Uh, and how can I now hold specific elements to interact with them without triggering any re-render here? This is what we use now ref for that, and how you can now pass a function call anytime that you get that. And then the rule of hooks, which is again, because you're hooking to React, it's a hey, um, this is the way of how you must use this. So hey, always use them inside of the React component, all right? Unless this is a custom hook, and always put your hooks at the top of that. The reason behind that is if you think about React doesn't have any native way to determine the order of your hooks. So if you're flipping from one state to another, so React right now doesn't know how to do that. The explanation can go deeper than this, but in any case, it makes a lot of sense to go with. So yes, and the other is revisiting immutability revisited, which is why do we even care about to always create these new objects here, and what these objects now are stored in. How do you can compare with that, right? And finally, the side effect, which is what do I really care in today's video? Jesus, 40 minutes to describe briefly that. Okay. Yeah, this is part of the exercise that actually allow me to hook into the use ref. All right. And the similar for media player as it is. That was quite interesting. Okay. And finally, the side effects, right? As we build applications, we often need to synchronize with external systems. And this can include things like making network requests, managing timeouts interval, reading and writing from local storage, listening for global events, or interactive with them. And React call all of these things side effects. In the lesson that follow, we'll learn how to use side effects effectively within our React application and about the best practice. Effects are hard. Okay, so let's take a look at this. Right. The ref, that's right, and the exercise. There you go. Exactly. So ref are not just for dumb nodes, but anytime that you want to store some piece of information, right? Dumb nodes, numbers, array, objects. Let's say the primary use case for ref is to store dumb nodes. It is pretty rare for me to need to store anything else because remember, we are now is building user interface. That's what React is all about. Side effects. Side effects. Right? Diggy diggy. You got it. Good. So, so React called this side effects, and side effects are quite hard to get your mind around. But let's get into this. There's nothing hard about this one. Let's get into this. So here, there are now the useEffect hook, the effect length ruled, rounding amount, exercise, cleanup, okay, exactly, cleanup exercise, stale values, state setters, callback, and more exercise, and a strict mode. And then you have now custom hooks and some data fetching and memoization. Let's get into this.
So far in this course, over the past couple of modules, we've been talking about this thing that React does that I'm going to call the core React loop. And it starts with us providing React with a chunk of JSX, which we can kind of think of as like a description of the UI that we want. We're telling React, hey, I need an H2, it should greet the user by name, I want a div of the class wrapper, and then it should contain a paragraph, and then all this other stuff, right? We have all this UI that we're describing, and React takes those descriptions and produces the real world DOM that the user can see and touch and feel. And as we talked about in the last module, it's not just about creating the initial UI, it's about managing that over time. And this is kind of how it's a loop. Because the user does something, like they press a button, this triggers a state change, which means that we rerun all this code, and now we give React a new description that in most cases is going to be pretty similar to the old description, right? Most of this stuff is the same, but then this span over here, it used to have the number 0 inside, now it has the number 1 inside. And so React takes that information and it like laser focuses on the parts of the DOM that have to change, and it makes this change, and then it waits for the next time the user does something, and on we go. This is sort of like React's main job, right? The primary thing that it does. But every now and then when we're building web applications, we need to do things that fall outside of this purview. And one common example is if we want to update the title. We see this a lot with social networks where like if you get a new message or if you have an unseen notification, it gives you like the parentheses 1 in the title bar. So if you're on some other tab and not paying attention, it's like trying to get your attention. Hey, there's something new here. So how would we do that in React, right? How would we update the title of the tab when that doesn't really fit into the primary purpose of giving it JSX and having it update the UI based on that? Well, in terms of like how do we change the title at all, for that we have to visit the index.html file, and we see that we have this title element, and if I change it over here sort of manually, we see that indeed changing this particular element produces the result that we want. But this element, the title element, it lives in the head, which means that it does not fall under React's normal purview because, we have this div ID root, which is the container that holds our React application, but now we want to change an element that exists outside of that container. React has a name for this sort of thing, and it calls them side effects. And a side effect is really any time we want to do something that's outside of React's typical job responsibilities, but still needs to be synchronized with the state that we're holding in React. Because if we think about it in this case, right, I want to update the title element. The title element
is that anytime that I need to synchronize this state Okay. Okay. So anytime that I need to synchronize uh, synchronize a state or a piece of information in React with other with other systems, whether they get APIs, you know, for example, web APIs or server APIs. Makes a ton of sense. mm-hmm. Mm-hmm.
React's typical job responsibilities, but still needs to be synchronized with the state that we're holding in React. Because if we think about it in this case, right, to be synchronized with the state that we're holding in React.
Exactly. So anytime I need to synchronize a piece of information in React with other systems, this is why we use useEffect. useEffect hook is the tool. So this is why I actually have is the use effect. Okay. Okay. Things started to make sense.
Because if you think about it in this case, right, I want to update the title element. The title element isn't controlled by React, so we want to synchronize this external thing, this other element, with the React state, the number of the count. And so we can definitely do this in React. React gives us a very specific tool for managing these sorts of situations, and it's called the useEffect hook. So I'm going to write react.useEffect, right? Effect as in short for side effect. And how it works is you pass it a function. And whatever we do inside this function, React doesn't really have much visibility into it, but React will call this function for us at appropriate times. So to actually solve this problem, right, to update the document title, I'm going to write document.title, and I'm going to make it equal to a template string. I'm going to add my parentheses and an em dash and write counter 2.0. And then inside these parentheses, that's where I'm going to interpolate in my count variable. And so right away when I do this, we see that the title updates to be parentheses 0 parentheses. And as I change the number in this thing, we see that it's not quite in real time, like there's a very slight delay, but I'm pretty happy with that. We can see now that it's 98 in both places. In terms of how this actually works, like what's actually going on here, essentially we've given React this function, and we're telling React to call this function immediately after every render. So whenever React wants to do an update, right, because a state variable changed.
So for example, in this case is this one, right? Using this particular example. So example here is because you are now synchronizing it with an external system, right? You are synchronizing it with an external system. So useEffect runs after every renders, right? So useEffect run after every rendering. So we can schedule a function that synchronize. Okay, we want to schedule a function that synchronize with an external system. Okay.
Or a prop has changed. Whenever something happens, React first does its main job responsibilities of doing the render process and updating the UI. But then immediately after that, it'll call the function that we give it. And because we've written in this function that we should update the document title, it will make that change. Now you might be looking at this and thinking, okay, I suppose that makes sense, right? I've written this function that React will call after every render, but do I need to do it this way? What happens if I do the exact same work, but without the useEffect hook at all, and instead I do it
So
in the
what
body
happens
of
is
the
that you're
counter component.
calling that
Wouldn't
on
this work
every
just as
render.
well, that while I'm rendering, I also update the document title? And in fact, it does work, and it works pretty much the same way. So you see now I'm still selecting random numbers, and that number is still showing up in the title. So why would we do it this way? Why would we overcomplicate our life? Well, it actually used to be a really bad practice to do things inside the render like this. It was just seen as this like dangerous thing where, the render process is for doing the primary job, and we don't want to be mixing our concerns like that. Over time, that belief has softened a little bit because people have realized that it actually isn't the end of the world in many cases. But there are still some very compelling reasons that we want to use the useEffect hook. Essentially, it gives us more control, more flexibility around how that effect is managed. And I'll give you one example. In this component, we have this name prop that we haven't really talked about yet. We see that we're using it
But
in
when
this
that name
H2. We see it in the screen. Hi,
again,
Yuka.
actually is
What happens when that
run
prop
this or
changes?
update this.
Well, as it stands right now, if this name changes, this whole component re-renders, which means that we're going to update the document title again. And we don't really need to, right? Like the person's name isn't included in the title. Really, we should only want to do this work when count changes. And that's one of the things that the useEffect hook allows us to do. And the way that it works, if I move this back within the effect body, I'm able to specify a second argument. And that second argument is always an array. And it's a list of the dependencies, right? The state variables that this effect depends on. So in this case, I'm going to add count. And I'm actually going to reformat this a little bit because I think it helps make clear what's happening. So the first argument is the function, the effect itself. The second argument is the array of dependencies. And what we've effectively said here is that React should only call this function when this count variable changes. So instead of calling it automatically after every single render, now it's going to ignore the renders where count stays the same. So if Yuka changes their name to something else, they can change it 100 times, and this code will never update because it's listening for the count variable to change. And only when that count variable changes will the function execute. I should clarify, no matter what I do with the dependency array, whether I have 1 item or 100 items or 0 items or no array at all, the effect will always execute after the very first render. So no matter what I do, this is always going to happen right after the component mounts, right? So when the page first loads, we notice that it updates the title to include parentheses 0, because that's what the state variable starts its life as. So that's one critical thing that I think is really easy to become mistaken about. The effect always runs initially, and then the dependency array allows us to control which re-renders we care about. So if it re-renders because the name changed, we don't have to fire the function, but whenever the count variable changes in a re-render, we execute the callback. There are some other pretty cool things that useEffect allows us to do, and we're going to talk about those as well. But our goal right now should be to get a little bit comfortable with how exactly this is structured.
Playing with this example. Run the code locally on your machine if you really want to dig into this example. Yeah, because it won't be able to look at that, right? But again, it allowed me to now synchronize with an external system. Okay, document navigator, document navigations, any of the web APIs. So web API, for example. Here, right? Battery status, only security context. Canvas API, right? The console, the clipboard. Right? So hey, do wants to now sync with this system here, the clipboard API, which is the interface, right? Read and read text, write and write text. The system clipboard is exposed through the global navigator.clipboard. You know, Navigator, for example, is another web API. Interesting. Okay, makes a lot of sense. Makes a ton of sense. What the navigator represents? The state and identity of the user agent. Oh, the state and identity of the user agent. It allows script to query it and to register themselves to carry some activities. The state and the identity of the user agent, right? So, but the whole point of this is that you can now is interact with this different API, right? Another common is the not only the encoding, the DOM, of course, fetch API, right? Uh, file API. There was another one, history API, Houdini's API, the HTML drag and drop API, media is this one, media stream image capture API. It's like, again, but all of them via the navigator. All of them via the navigator that describes the state, that describes the state of that. But again, you get the idea, right? Sensor API, servers and events, UI events, URL API, URL pattern, vibration, web API, right? Do you create an audio context with the inputs, effects, and the destination? But again, you get the idea here. Interesting. Web codecs, API, web workers, web storage. Not sure if this actually using property Windows season storage and local storage. But all of this part of the web APIs. Okay, this is what you can synchronize to this external system, and if you want to now hold these schedule functions when a piece of information that you are tracking of change. All right, makes sense. Strict mode, gotcha. Before we go too deep into the useEffect, I want to mention a really common stumbling block. As you use React outside of its core platform, you might notice something a bit curious. Effect seems to run twice when the component first mount. Oh, this is because React 19 on the strict mode, it will automatically run certain chunks of code while working on our application. This is to highlight potential issues. For now, strict mode is disabled on this course platform in a few lessons. The strict mode gotcha here. The strict mode gotcha. Okay. And then we can look at the exercise, right? Logging a particular value. Okay, exercise. Okay, exercise. Logging a particular value. Below, we have a sign-up form with several React state variables. Our goal is to add a console log that fires only when the value of email change. Okay, we should see the user email login and the console whenever they edit that field, right? Whenever the user change the value of the email state variable, the new value should be logged to the console. So whether it's by showing us this, nothing should be logged when the user change another field. For example, their city or postal code. Exactly. What happened is look at this. That's a very interesting issue. So here you say, if I put console log to all of this, I go to Indeed, on every render, going to see is the preferred name, email address, city, and postal codes. But if I want to now is detect that, all right, which is synchronize with that event, and here on the field, all right, that's interesting. Okay, so what I can do is instead of detecting that at this level, is just only at that particular field, which is the field component, right, is to so when that change, so in other words, is detecting when that property changed, and when that happens, all right, I do want is to show this. So again, useEffect, we can use an useEffect here, but I think that we are coming exactly, right? So React.useEffect, I can pass now a function here, right? And then say this. I just only want to run once, and here, whenever the onChange function value change, all right, well, I just want to is show the value here, right? But I do need, in fact, have to pass the value as it is. So when the onChange value change, aka is when somebody is now calling that function, all right, or when that specific value actually change, and since the criteria here is that whenever the user changes the value of the email state variable, the new value should be logged to the console. Whenever the user changes the value of the email state variable, the new value should be logged to the console. Nothing should be logged when the user changes another field, for example, city and postal codes. So what I can say is this: hey, what is the type of this input, right? So if the, let me put it this. So I'm gonna check is the value and the type, right? So if the type of this is equal to email, right, then what I can do is to, well, actually render that as it is. It's not assigning, it's comparing here. So now this will work as expected. So not only this, nothing here or here, but when I do here, I will see this several times here, right? You see, only when that is here. This is quite interesting because this allows us to have now fine granularity of how these components change and when that change.
So I've been using JavaScript now since like 2007, and I have yet to find a more versatile tool than console.log when it comes to debugging. And suppose that I'm curious about what the value of email is, maybe I'm not seeing the output I expect, I can add a console log email, and in fact, I'm going to be a little bit fancy and wrap it in object notation so that I get this nice labeled output. I can do this, and it'll absolutely work, and as I start changing things, I see it being logged. The problem with this, though, is that as I start changing the other fields, I'm filling my console with all sorts of nonsense. Like it's logging every time I change any field. And while this isn't like the biggest problem in the world, it is a mild nuisance, and it's something we can improve with useEffect. So here's what I'm going to do. I'm going to get rid of this code for now, and I'm going to add a useEffect hook. Inside this callback, I'm going to paste in that console log, and then I'm going to add email as a dependency. With that done, it's only going to run this code whenever this variable changes. So as I start typing in the email field, I see it being updated. But as I type in the other fields, nothing at all is logged. The silence is beautiful. Now what about this stretch goal, where I want to log not only the email, but also the name? Well, I could add name to this console log. When I do that, I get a squiggly red underline and a lint warning. Now we're going to talk much more about this particular lint rule in a lesson ahead, so I'm going to sidestep it for now. And instead, I'm going to show you the problem with how this code is set up. As I start typing in my email address, everything seems to be working all right. But then when I start typing in my name, notice I'm not getting any log output. Like there's no output even though I'm changing my name and I'm logging my name. Well, this happens because I haven't told this function to rerun whenever name changes. I'm only listening for changes to email. And so if I add name over here, all of a sudden, check that out. I see the most recent value gets thrown in. And now as I change either of these fields, I see them both get logged. Now this is a perfectly valid solution, but I actually think there's an even nicer one. So I'm going to go back to how it was with just email, and I'm going to duplicate all of these lines. And now this effect is going to be about email logging, and this one is going to be about name logging. Check out how nice this is now. As I start typing in my name, I get this nice clean object showing me that my name is hello. And then as I start typing in my email address, I get a different very clean log showing me what my email is. It's easy to fall into the trap of thinking that we can only have a single useEffect call inside a component, but actually it's recommended to have as many as you need so that each of them only deals with a single concern. So this is my preferred solution, although as I say, right, both of them are perfectly acceptable.
In my case, and I do get why you do that, is because that actually works as expected at the component level, right? But if you want to now make things more simple than they are, right? You can is either exactly. So go. What's the best practice here on useEffect, right? A few students have asked if we should really be using effect here. Wouldn't it be better to add a log to the event instead? There is a subtle semantic difference here. It depends on whether we care specifically about the user editing text in this input, or if we want to track the state variable more broadly. So if you do this, it's gonna get trigger is whenever the bottom do that thing, right? In case like this, I have a clear preference for using an effect. It is a lot of more bulletproof. I don't have to worry about forgetting to do it in one place, and I can trust that the side effect will always fire whenever count change, no matter what the trigger is. Now when we only have a single trigger, as we do in this sign up form exercise, I honestly think either approach is fine. Exactly. I should note my preference here diverges from the official recommendation. The React does encourage you to put stuff like this inside of the event handlers. I personally don't see anything wrong with using effect this way. So I had say you should do whatever makes most to you. Sending a post request. Good. This logic should be run the component we're displaying. You're running is this, right? And avoid event specific logic inside of an effect. Like this. Avoid event specific logic inside of effect. Part of the recommendation, which is exactly what I did here, I define is a condition here. There is nothing wrong with that. There's nothing wrong with that, right? Right? There's nothing wrong with that. But the recommended way to say, hey, this logic should be run because a component was displayed, right? And not adding some things like this. So don't polluting that as it is. This is part of the rules of part of the rules of the use effect. Okay, part of the rules of the use effect. So anytime you want to synchronize in this case with this, right? And then you want to now say, hey, I do get the name, and whenever the name change, I do want to now console log is the name as it is, right? Just like that. And I need to is define this as a React use effect. So whenever this change now, you say, hey, the preferred name will be this, where others don't. But now the other is using the count for that. Console.lock, right? The thing here is that you're not synchronizing with, well, you are indeed synchronizing with an external system here, right? You are now is with this thing that live outside of React. But the other is, hey, when the name change, I do want to now run is the name as it is, right? So of course initially is this, and when this change here, the others won't render because it's only exclusively triggering is this specific event. That's it. Only this, right? So whether you're using useEffect for this or another one, the best practice here is doing that inside of that. Locally persistent state. Let's suppose we are building an application with a dark mode toggle. Let me do this. Okay. What the? Locally persistent state. Let's suppose we're building an application with a dark mode toggle. It will be really annoying if users have to keep toggling their preference mode every time they load our application. Let's update the code. So let's update the code below so the user preference is saved in local storage and restored when the page loads. In other words, the current value is dark mode should be remembered and used when the page is refreshed. So in other words, here we're going to use is now we're going to synchronize with an external system with an API, web API, which is the local store, right? So you can do this in plain JavaScript with the following code, right? Accepting criteria. The value is dark mode should be saved in the local state, local storage whenever it change using the useEffect hook. The initial value of the dark mode state variable should be retrieved from the local store or set false if no value has been saved. You can use the string is dark mode for the key. Note, items saved to local store as always save as a string. You will need to convert the store value back to Boolean. You can do this with JSON.parser. And then you have the local storage gotchas. This exercise use the local storage API, which can lead to some frustrating issues. If you're getting funky errors even after refreshing the playground or copy pasting solution, you will want to clear your browser local storage. I have created a local storage troubleshooting which show how you solve this most common issue with local storage if you're having any issue with this. Okay. Persisting invalid values here. resetting local storage. Exactly, it's resetting local storage. So let's get into this. All right. So local storage cheat sheet. You're gonna use this to set to true, and to retrieve the value from that, you need this to parse that, because you get that as a string. That's right. You need to parse that is. So here, what I wanna do is this. So React use effect. All right, and here you're going to run once. All right, this is the function I'm about to schedule, and here is this, and this is window local storage. So I do want is to retrieve any value here, right? And yeah, retrieve any value here is dark mode, right? So let me is retrieve that value, and in this case I do need is to, whenever this thing change, I'll do need is to update that, right? So is dark mode, let me ask here. So window dot local storage dot get item, yeah, dot get item, and you say, hey, exactly, is dark mode, right? And if you have any value, return it. Otherwise, then this is false, right? Pretty much straightforward like that. Oh, because this is now, I do need is to parse this JSON dot parse to this, right? Assignment to the is dark mode. Oh, of course. Yep. That's interesting. That's a very interesting thing that happened. Okay. So here I'm just is getting the value, right? Here you say, hey, get mode, right? Or dark mode, or is dark mode, is dark mode. If it is, good. If it's not, well, this is false, right? And then I do need to sync this piece of information when this is dark mode. It's like, holy hell. You know what I mean? That's good. Okay. Mm. Mm. Whether if I do this, right? And then I try to update the state here. Set is dark mode, right? To read this state. This will only this will now run is once, and it's going to read that piece of information out of that, and then now set to that, right? Mm-hmm.
So this exercise can be split into a couple of parts. In part 1, we need to figure out how to save the isDarkMode state variable.
Wait a single moment, because I'm just retrieving is this data, right? I'm just retrieving is this data, and then I need is to set that data, which is going into this handle toggle as it is, right? So here I'm going to get a value, which is a toggle, and this toggle, how do I get this piece of information? Do I have access to that information as an event? And on click, it's going to handle toggle here. What the French toast? But here, what I do want to do here is this, is that not only the hang toggle, which is a function that is going to be passed down here, is going to be called here, but I'm going to now is pass down this value here. Okay, so in other words, I'm going to receive is the value here, which is good. So here I can set the value here, all right, and or set the value when the things change. That's interesting. Yeah, that's quite interesting. So I can do is this, or I synchronize this to set the state here, right? And then I can now synchronize this when the isDarkMode change to actually is set the data. And this setting the data here is you say, hey, window, I say window dot local storage dot set item, where the key is this is dark mode, and the value, which is dark mode. So when this change, you're going to only synchronize with that state, and on the initial render, you're going to now is read that data from it. So when you reload this, you're gonna get that data. You reload this, you're gonna get that data. You go back here, you reload this, you know. That is very interesting piece of information here. Exactly, because you only want to run this only once, and then when this data to update, to synchronize with that external system. Okay, holy hell. Okay. Mm. Mm.
So that it lives on beyond the current browser session. And in part 2, we need to figure out how to retrieve that value and use it as the initial value so that the user's preference is restored. And for the first part, we could do it right here in the render, where I say window.localstorage.set item. I'll make my key is dark mode, and the value will be the is dark mode state variable. And if I try this out now, like I toggle this on, and then I pop open the dev tools, we do have to do a little bit of digging. So first you have to go to the application tab, then you have to expand local storage, then you have to select one of these sandpack bundler tabs. This is essentially the little iframe over here. If you're wondering why there's 2 of them, that's because there are 2 sandboxes on this page. The good news is that they both share the same local storage state, so you can pick either one and it'll work equally well. And what I notice is I have this is dark mode key set to the value true. If I flip it to false and then refresh, I see that it is indeed tracking this value pretty reasonably. If I clear local storage with this little clear icon and then refresh the page, and then refresh local storage, I see that it even initializes it during that very first render, and so everything here is looking pretty good. But it does seem a little bit wasteful to be doing this in the render like this, because it means I'm going to be setting an item in local storage on every single render, regardless of whether or not this particular state variable changed. Now, I do recognize in this contrived example, there are no other state variables, so it doesn't really make a big difference. But if we imagined having 5 or 10 other state variables, including ones that might change a lot more often than the user's dark mode preference, it starts to become a bit of a concern. So here's what I'm going to do. I'm going to add a useEffect hook. Inside the hook's callback, I'm going to paste in that code, but I'm going to add a dependency so that this code only runs when is dark mode changes. So that seems pretty good for part 1. But as we notice, right, setting it into storage is one thing. I also have to get it from storage to use as the initial value. And so here's what I'm going to do. I'm going to get stored value as a variable, which is going to be equal to window.localstorage.get item, passing the same is dark mode key. And if I console log my stored value, we'll see what we get from it. I check the console, and I see something that's almost right. Like I see stored value, which is set to false. If I come over here and click the little toggle and refresh the page, I see that it's true, but notice that it's the string true. It's not the Boolean value true. And the reason for this is that local storage is only capable of storing strings. I'm not allowed to store numbers or objects or Boolean values. And so I'm going to create a new variable called parsed value, which is going to be equal to json.parse stored value. Then I'm going to use this parsed value as the initial state, and we can try out how that works. So I toggle it on, I refresh the page, and hey, check it out. We're still in dark mode, and it works exactly the same way, regardless which value is set. But before you start popping champagne bottles, there are a couple things with this we need to address. The first one is what happens if we don't have a value in local storage. So if I clear this all out and I refresh the page, if I refresh my local storage, notice that is dark mode is now set to null. And this happens because if get item can't find a value, it evaluates to null, and that's what winds up getting set as the initial value. Granted, that doesn't really make a big difference, like null is falsy, and so for all of these expressions, we still get the same initial value, but it feels a bit funny to me that I have this is dark mode state variable that can be either true or false or null. So as a backup, I'm going to add an or and pass false so that if this is any other falsy value, like null or undefined, it'll use the false Boolean value instead. Now, the last little thing I want to address, once again, is a performance thing, where I don't necessarily want to run this expression on every single render because it's expensive to interact with local storage. And especially in this case, like, I only need to get the item for the very first render to figure out what the initial value should be. I don't want to have to do that on every other render. Fortunately, we can use the alternative form factor for this, where if I pass a callback function instead, I can move all this stuff up into it, and I can return this parsed value. And now when React renders for the very first time, it'll call this function, running this code, and figuring out what the initial value should be. But on every subsequent render, it won't.
It won't.
Now, you may have noticed my UI is broken. Fortunately, this isn't like a real problem. This is only a problem because the hot reloader fired before I was ready. If I go into the browser and clear my local storage and try it again, everything works the way you would expect.
But again, I didn't use a hook. So I use a hook.
So this exercise up into it.
I use a hook to synchronize with this external system, but not to do this kind of stuff, because that to me was quite weird thing here. So instead, what I can say is, hey, I do wants to now is call this function only on the initial render to set up this, right? To set up this, right? And then return is dark mode here, right? You say undefined is not a valid JSON, because what I'm trying to parse here is this window the local here, diggy, return is the value here, or false in this case, right? And it says something went wrong. So if you reload this, it says something went wrong. But here I'm just passing is these functions to say, hey, is shadowing this value, right? So yeah, it's dark mode as it is, and then I want to return is dark mode. Window the local storage get item is dark mode. If that exists, which is in a string, I want you to parse that into now some value JSON, right? Undefined is not valid JSON. It say window the local get item ID. That's quite interesting. But I do want to parse that. Yeah, JSON the parse of the store value. If it's not, then return now false, and this is what you are going to do, right?
And I can, what the initial value should be.
So whether you use is the store value as it is, whatever store value you got here, and then you say, hey, JSON parse the store value, which is now in a string, and if that give you now undefined, you can pass is to set to false. It say, hey, I'm trying to parse this, right? Window local storage get item is dark mode. Once it's tried to parse that, JSON parse as the store value here. So if I reload this, or if I reload this completely, and then I do this, it's an unexpected token O, store value, or false. So if I reload this, object JSON is not a valid option. Unexpected token here O of object JSON. So here I'm getting is this window.local storage get item as a store value, and then return that parse value here. Window local storage, yeah, I'm using is the window local storage. Get item is dark mode. It should return me something here, and then I want to compare that, but for some reason it say no, that's not. So in this case I will need to dig in into the application, right? Go a little bit further of the extension storage. No, it's not the extension storage, it's the season storage. Here I got another iframe that I'm trying to store that information here. So when I try to refresh this, so no value here, or even here. It throw now this specific error, but let me refresh here to see if that actually is working. And it continued to throw this specific error here.
To it, function running this code and figuring out what the initial value should be, but on every subsequent render, it won't.
Unexpected token O. But is here is window local storage get item here. Okay, so if I reload this and now I hit here and then I reload this, I should preserve that. But this is interesting because instead of using now I use a state to set the state that no matter if you're running on the first render, if you want to set values on the first render, you do that using now the function that you're passing to. Holy moly, bro. One more thing, the solution share here won't work if using a server-side rendering framework like Next, Astro, or Remix. And we'll learn about this scenario and how to work around in the Module 6. This pattern is discussed in the use state hook lesson. Exactly. An alternative solution is that you either pass that on-chain code committed, and then you define now this function as it is, and then set its dark mode to this. Instead of using it as useEffect to track the chains in dark mode, we could also create a new setter function that tackles the local storage right. For example, like this, and anytime that this function is called, you're going to now set that over and over. Our new function set inside wraps around the state setter function we get from React. Whenever we call this function, we'll update the state and perceive the result to local storage. Like I mentioned in side note above, the React team generally encourages us to put stuff like this inside event handlers rather than using effect. But I disagree with this recommendation. That say, I also don't think it makes huge difference. Ultimately, both approach will just work fine. And then the effect link rules. So yeah, that'll be all for this video. Take care. Bye bye.